Right, silence, please. We're going to start anyway, even though we're hoping there'll be some more people will arrive. Right. Okay, hello everyone. My name's Ross, and I'm here from London. So first of all, thank you for having me over here. This is awesome. I've been looking forward to it for a long time. And today I'm going to talk to you about MySql Type Provider. So firstly, a little bit about me. Not too much, you'd be glad to know. I've been programming computers pretty much all of my life, and probably 16 or 17 years professionally. And in that time I've used tons of different languages and technologies and done all kinds of different things. So I'm not going to go into any detail about any of that. In terms of F#, I've been working with F# for just over 3 years or so. And okay, yes, and one of my things that I really love about F# are of course type providers. So some of you know about my work. You probably know some of my type providers. The ones on the left are the ones that I like, and the ones on the right are almost certainly a lot more useful, but nowhere near as interesting. So what we're going to be talking about today is the IQueryable erasing SQL type provider, the one over here. And all of these other crazy ones on the left we can maybe talk about later after the talk is finished. Right. So just as a little bit of a background on the ancestry and heritage of, as it were, of this type provider. So some of you might have seen the free-base type provider, which Don Simon originally wrote, and that was the first F# type provider that had an IQueryable implementation, although it was a very, very minimal implementation, and it doesn't really implement hardly any of IQueryable at all. So I worked for Microsoft Research for 4 months at the beginning of last year, and I wrote the Microsoft Dynamics CRM type provider, which you may have seen. And that is a full implementation of IQueryable, which was the first type provider to do that. So the type provider I'm going to show you today is an evolution of the Dynamics one, and it is largely based on that original code base, although it's come quite far since then. So, yes. Oh, so you might be thinking, well, Ross, we already have a SQL type provider. And actually, the first time I did this talk, there was still, well, there's 3 SQL type providers, right? Hello guys, over there. Yours is one of them. So originally there was the type providers that were released from Microsoft, which will generate code, including the Entity Framework, the SQL provider, and the WSDL type provider. So I started to work on this to replace, or effectively give us a better version of the SQL type provider that was released by Microsoft. At the same time, the guys from here, the New York Meetup group, also released another SQL type provider, which is called fsharp.data.sqlite. Now they're not in competition. They do 2 different things. So the other type provider is awesome as well, and it allows you to use arbitrary SQL statements in a type way, and it also has much better support for stored procedures. So whereas this is more about schema exploration and being able to write LINQ queries and be able to easily update entities. And also, I don't know, I'm not going to drop you in this. I think that yours only uses SQL Server as well, and this is aimed to be an open source thing which can connect to nearly any data source, although I guess that might change later. So the reason why I actually did this work initially, like I said earlier, was to replace or try and enhance the type provider from Microsoft, because it has several glaring weaknesses. The biggest ones are the fact that it uses SQL Metal to generate code in the background. So if anyone's used SQL Metal, or if you've used LINQ-SQL and C#, you'll know what SQL Metal is. And because of that, it suffers from all of the problems that you have with SQL Metal. Namely, it generates a hell of a lot of code. There are ways that you can configure it to not generate everything in the database, but you have to fiddle about a lot of config files. So essentially it doesn't scale, and you definitely can't plug it into a huge database. Okay, and then the other big one here is that it's closed source. Right, so you can only access SQL Server with it, and it's closed source, so you can't really extend it in any way. So what I wanted to do with the erasing SQL type provider is to remove a lot of them issues. Namely, because we erase, there's no code generation, which means it can scale to huge schemas, and also it supports any number of database vendors. So at the moment we've got, as you saw here, SQL Server, SQLite, MySql, Oracle, Postgres, Microsoft Access, and ODBC. And ODBC was just added recently, which is really powerful, although it is weak in some ways. But ODBC means you can actually use the SQL Type Provider to use spreadsheets, Excel as well, which I'll show you in a minute. On the flip side, the type provider at the moment, it doesn't really support a lot of the LINQ functionality. So there's no group by, there's no nested queries or anything like that. Also, I don't support any math functions or anything like that yet, but that's stuff that will come in the future. So this talk is actually largely about the architecture and implementation of the type provider and how to implement IQueryable. But first, I'm just going to do a little demo of some of the features. And I'm not going to concentrate a lot on this, because it's not really about the features so much. Okay.
Show the second screen there.
Right, I ended the PowerPoint presentation.
Visual Studio is here. It's coming up on our second screen.
You can see the window peeking out on the left.
Okay, that was bizarre. Right, so I assume everyone knows how type providers work, because this is quite an advanced type provider tool. So just to talk through a few bits of this. In these lines here, where we actually create the type provider, in this case I'm using a SQLite database, and we do have this other flag here, static parameter called resolution path. And the reason that exists is because at the moment, although you can connect to a wide variety of data sources, it's still only one type provider. So because they rely on third-party libraries, you have to kind of tell it where them third-party libraries live. Now in the future, we'll probably create a series of packages that include those dependencies with it. It's also quite tricky though, because with something like SQLite, for example, you have to have the right architecture depending on the system that you're working with. So that is a little bit gnarly. Okay, so at this point, once you've given it the connection string and the location, you can now get this object which is called data context, much like it is in SQL method. So when you press dot here, it gives you access to all the tables and all the views. Also, you'll see here store procedures. Well, SQLite doesn't support store procedures, but depending on your database vendor that you're using, you can call store procedures. The support for it isn't great. I did it as a last-minute kind of thing, and the other SQL type provider does a much better job of it. So, I'm not going to be showing that stuff today. So, at its simplest level, you can treat one of these guys as a sequence, and it will evaluate that and bring back all of the rows from the database. So I've got a little helper thing here. We'll show you that. Okay, so it's not particularly interesting. So one of the nice features that we have in this erasing SQL provider, you can create entities here. And then we have this property called individuals. So if you're familiar with the free-based type provider, you'll know about this concept. And what this does is it actually looks at the rows of the table and it projects them individually as a separate type. You can limit the amount that it uses via a static parameter. So if I press dot on the individuals, it gives you a property for each row, and it uses the primary key as the text of the property, which usually isn't very useful. It actually is usually a number. In this case, it's a string, which is some code to do with their name. But to get around this problem, there's also another property for each column in the table, where you see here as address, as city, etc. And if you press dot on these again, what it does is it takes the data and it reprojects it. So you end up with this with the primary key and the value of that property. So this might seem a bit odd at first, but it's quite useful for data exploration scenarios. And also, if you use static data in your programs, this can actually be really handy. So if you see, we've got this guy, Thomas Hardy here. So this is fairly interesting because now it means that if someone changes his name in the database, it won't compile anymore, right? Which can have some significant benefits depending on what you're doing. So, and as you'd expect, we have properties for each column in that table. And you'll see the type here of T is this customer's entity. What it actually is, which I'll show you in a minute, is this object that I call the SQL entity, which is effectively a fancy dictionary. Okay, but we'll be going into quite a lot more detail in that stuff in a little while. So one of the other things that we can do on, assuming you have one of these four entities, is you can also look at the foreign key information, assuming that you were able to get that from the schema. So you'll see here, for example, this is the name of the foreign key constraint, which is called orders. And you can see here it relates the orders entities from the foreign side of the relationship, where the primary key is customer ID and the foreign key is customer ID. So what this is the orders of Thomas Hardy. And this is pretty awesome because it means if you connect up to a database that you don't really know about, often it's a pain finding about what relates to what and how, and you have to stalk through SQL Explorer or some description and work out how to join tables together. And this will actually just do it for you. So this is another IQueryable sequence. So at its simplest, again, I can run this. Okay, and then that gives me all of Thomas Hardy's orders. Now, obviously, I was going on about this being IQueryable, so you can use F-sharp query expressions like so, which you can do a lot of the things which you would assume. However, there are a couple of little neat things. There's a few special operators you can use, such as this one, which is like. We have like, not like, and in and not in, which I'm probably not going to really show. And also in the projection at the end, you can use any F-sharp expression. And equally, if I was to put in here, like only select company name, then the SQL that it generates will only select that one field. Whereas if you select C, then you get this whole entity back, which you can then mutate and submit updates to. Right, so one thing I'm just going to touch on here before I continue. There's two ways that you can join to other tables. One is, obviously, you can use the explicit join syntax in a query, and the other is that you can use what we were just seeing above with the foreign key constraints. So this is the select many syntax by using another for. So effectively what this does is it infers the join information for you, right? So once again, you don't need to know about how to join table X to Y, it sorts it out for you. And if for some crazy reason your database actually changed the way that works, it wouldn't break your code. Not that that's really ever going to happen. Right, I'll briefly touch on some of the other stuff you can do with it, but just before I continue, I want to show how you could use several of these type providers together to do some pretty cool stuff. Up here you saw that we get a data context object. By default, this uses the connection string that you use when defining the type provider. This is a fairly common pattern in type providers. In here you can also specify a runtime connection string. And this is something to bear in mind when we talk about the architecture of this stuff, because it means that you can have several connections that use the metadata that has come from this connection string, but actually you pass it a different connection string at runtime. And equally, you can have several different type providers that connect to different databases, all of which can have several different data contexts. And some of the stuff you can do can make this very easy to replicate data between the databases. So in this case, what we do is use the ODBC provider connection string, which is really ugly, ODBC stuff, and it connects to an Excel spreadsheet that I've got on my desktop. And then here, much like above, I can create a type provider, and now I have this employee spreadsheet, and you'll see this is sheet 1 of the spreadsheet, right? The individual doesn't work here because there's no primary key. You have to, the individual's functionality doesn't work unless you are able to tell it what a primary key is. But yeah, you can just treat this as.
Can you run VBA scripts as stock position?
Sorry?
Can you run VBA scripts as stock position?
For the video, the question was, can you run VBA scripts with stored procedures? Yes, probably.
Good idea.
Yeah, well, no, you'd have to do something custom for that though, right? Because it's not, the thing with ODBC is you're limited with what schema it gives you. And the ODBC SQL syntax is fairly limited. The ODBC support is actually quite new as well, so we're still working on it. It was written by another guy as well, which is nice. Nice to have contribution. So at this stage, this spreadsheet has got 2 columns in it. It's first name and last name. It happens to match exactly to the employees table in the database, the SQLite database that we were using earlier. So this function here, it just maps each entity from the spreadsheet, and it calls create on the SQLite database. And actually, if you look at this function, it has several different overloads. One is a blank one, so then you can set the properties you want yourself, and it expects you that you know what the ones that you have to set. There's another constructor, this one, that lets you pass it in any sequence of a tuple of a string and an object where the string is the name of the column. So this is a little dangerous because it assumes that you know that the data coming in matches. So that one's a little dangerous. And then finally, this constructor forces you to pass it in the columns that are marked as requirement. Okay? So in this case, you could have easily, equally, manually map these two together. But because I know that they're the same, you can just do this as a shortcut. And that's actually enough to take these new employees out of the database. And then you can submit updates like so. And that's it. That's a transactional update as well. It's these two at the bottom that just went in. Okay, so this illustrates quite a powerful concept because, especially if you have 7 different versions of the same database and you need to replicate data, or you need to do extract, transform, load procedures between different databases, this is a really powerful way to do it, and it's safe as well in terms of transactions. Okay, so I'm not going to talk any more on this, but just as an example of a bigger query and the different bits of the LINQ syntax that you can use. At the moment, there's some here, including the in syntax. This has just been changed recently. It uses a new array expression here, but you can use any sequence. So you can actually use another query there, but it won't do anything flash. It will just run the other query. Right.
What's the TIE fighter operator?
Yeah, that's the in.
Oh.
So that's in. The TIE fighter operator is in, and the TIE bomber operator is not in. That's Darth Vader's one, right? And equally, this is like, yeah, and then this is not like. Okay, so we could probably add some more of them later.
That function that you were calling in interactive show, is that built in?
Oh no, I'll show you bits. I'll show you bits. Pun not intended. It's this little script here. Actually, you touched on a point which I forgot to mention. And I forgot that I implemented this because it came from the CRM type provider, but the SQL entities with some trickery do support WPF data binding on their provided types, right? On provided properties. So this is the code that's being called there. All you have to do is wrap the results in a binding list of an entity, and yeah, you can just bind it. And actually, this is really awesome because I just realised the other day that there's 2-way data binding. So when I showed you the group that popped up earlier, you can actually edit the data in there and then we'll submit it. And you get all of that for free just with that little tiny script. So that's pretty awesome, I think.
You should use array types, right? Ace type? Is it the ace types?
Yes. I'm not going to have time to show you how it's done, but look at the code.
Right.
Right, this is. Right, this is the new version of PowerPoint, and it doesn't let you Alt Tab away from your slides. You have to end the slideshow, or even though I don't know how to do it yet. Okay, so.
Have you tried Windows tab?
Yeah, it doesn't work.
Oh.
Right, so we'll talk a bit about the overall architecture of the type provider, and then I'm going to talk about the design time stuff, and then finally the runtime, which will be the bigger bit of the talk, and specifically about problems you get attempting to implement IQueryable. So type providers are hard to write, right? I mean, if anyone's tried, you'll know they're pretty difficult. It's a lot of meta programming, and it's pretty tricky anyway, but when you go beyond trying to write a fairly simple type provider, and you actually need, for example, different runtime implementations, or like, as I explained earlier, where we have, we share, this type provider can have many versions of different databases going at the same time, and each one of them can have multiple different data contexts, and each one of those data contexts tracks the entities that it knows about so that you're able to perform these transactional updates. So when you start getting into this stuff, it can get pretty tough to write. So just to describe this diagram a bit, which isn't actually complete. It's really hard to draw this stuff. Yeah, but going from the top, this is based purely on ADO.NET, right? There's no entity framework or anything. It focuses around the IDB connection, IData parameter, and IDB command, or whatever it's called. And then I'll have this interface at the top here, you can see, called the IC provider. This is the guy that you implement if you want to extend or add another provider. Okay, so there's an implementation for each one of the 6 or 7 that I discussed earlier. And that interface is responsible for many things. It's responsible for both giving the metadata a compile time, and it's also responsible for executing the queries at runtime and generating the queries themselves. So at compile time, the type provider asks via this IC provider interface, says, give me some information about what tables and views exist, which is the schema metadata. And it does this lazily, right? So at the start, it just says, give me a list of tables and views, just their names. And from that, it creates what we call provided types. So provided types are the fake types that don't exist in the runtime, and at runtime, they get what we say erased down to another .NET BCL type, which is this SQL entity over here, which you were seeing earlier. So just to clarify here, because I was asked this in London, what is this definition of an erased type? There's nothing special about an erased type. We only call it an erased type, so to indicate that it's something that a provided type gets erased down to a runtime. There's nothing special about it. Right, so the way that this bridge is actually, the gap here is bridged, and if you know anything about type providers, you already know about this stuff. And we use F-sharp quotations to map from the fake types down to the real types. So in this case, the SQL entities that exist, as I said earlier, it's basically a dictionary, and they have these functions on them called, get column, or what have you. So when we create the provided types, they use these quotations that map to them functions on the underlying type to actually give us the data back. Okay, and then at runtime, this is the IQueryable implementation, which I'll be showing you a lot more later. And the link tree is processed, and the query is formed from it. And finally, it gets passed to the IC provider interface, which generates the query text itself and executes it against the database, and then brings this stuff back, and you end up with this SQL entity, which might have been a little confusing, but it will make more sense when you see the rest of it in a little while. So, just to go into a little more detail on how these provided types work, in terms of the entity attributes, or the columns, in the database. Okay, so here the boxes in the middle represent a provided type each. This is for each table in the database. And then each of those tables has different column names, right? As you can see. And then at runtime, all of this disappears, and you just end up with this SQL entity that is just a dictionary, just has the key value there, which I already explained. However, I showed you earlier this idea of servicing the foreign key constraints on the entities. Now this stuff's a little different because the foreign key information is just information. The Thomas Hardy's orders earlier, they're not a property of Thomas Hardy. So in terms of this SQL entity, it doesn't contain that data. All it really does is contain this IQueryable reference to it. So this actually has to work slightly differently because at runtime, in order to actually retrieve that information, something else needs to happen. And what that is this data context again. So we have this idea of a data context and a SQL entity, and they know about each other. Okay, a SQL entity has a reference to the data context that it was created from, and equally, the data context knows about any entities that have been changed that it created. So, and in this way, we surface a property for each foreign key, such as this company to employee, and then at runtime, I'll show you this stuff in a second, that actually calls a method on this data context, which is called createRelated, with all of the foreign key information. And because at runtime, it also knows about what the primary key is of this entity, it's able to fill in that missing bit of information, and we retrieve all of the data. See, look, this has done this again. When I run the PowerPoint, it automatically extends it, and then I have to duplicate again to show you the code.
It's annoying.
Yeah, so I'm not going to show you much of this design time stuff because this isn't the talk's more about the runtime information. But I wanted to just show an idea on how some of these quotations work. So here, this is where we create the relationship, the foreign key stuff, which is slightly more complicated. And in this code, we've already got the information from the MySQL provider interface about the relationship data here. And then this quotation. So if you know anything about these F-sharp quotations, a provided property, it gives you this argument list, which is a list of expressions. And the first expression there will be the instance of the object that the property is on. Okay? So in this quotation here, it gets spliced, and we extract the SQL entity out, which is the thing that the property is on, the runtime object. And it has this property of the data context, and then it calls this createRelated, as I just explained. And the first method, the first parameter of this is the SQL entity again, and then all the foreign key information. And what this actually returns is an IQueryable of SQL entities. So actually here at runtime, it's just SQL entities again. But as far as the type provider is concerned, that's actually an IQueryable of whatever the provided type is of the relationship in question, right? So I'm not going to show much of this stuff to do with the quotation. And instead I'm going to struggle with trying to show you the quotation. Okay, right, enough of the design time stuff. So this slide tries to explain what happens at runtime, and this is quite interesting. I'm doing a lot of work with compilers and things at the moment in my current job, and I realised the other day that the SQL Type Provider it is a compiler, but actually in a weird way it's also a bit like an interpreter as well. So just to run through this, at runtime when we evaluate a LINQ query, the F-sharp compiler picks it up and it generates a LINQ expression tree from system.link.expressions. And essentially we find this LINQ abstract syntax tree to deal with. Okay. And actually you get several of these trees depending on the query, which I'll show you in a minute. And from that information, I pick out the bits that we're interested in and I build up my own SQL abstract syntax tree. And at the end of that process, we've then got enough information to go and fill in some holes and gaps in that AST. And once that's actually complete, able to then reduce that hierarchical structure down into a more flat structure that's suitable for generating SQL from, which is this SQL query type. And at that point, it's then passed over to the individual implementation, depending on the database vendor. And then here, an optimization step happens. Or well, an optimization step doesn't happen at all, but if it was going to, that is where it would be. So if anyone fancies, you know, writing some optimization code for a specific database vendor, please be my guest. Okay, and then finally, we can actually generate some SQL for the specific database vendor. Once that happens, that gets passed back out of the interface, and then the general structure goes and it runs the query against the database. And then there's this final step here, which takes the projection expression of the LINQ expression and actually projects the result. And there's another slide on this later because the projection's a little bit tricky, as I'll show you shortly. So, hope that makes sense. So, LINQ.
What if you build custom query builder? Do you still have to deal with the...
No, right, so you raised a good point about the custom query stuff, and no, you wouldn't have to. So originally, because this was based on freebase, and we went with IQueryable, and IQueryable gives you some benefits, like, you know, that syntax is already there, as long as you implement most of it, or all of it. And also it means that you can plug some of this stuff into other places that accept IQueryable. So it does have some benefits around there, and retrospectively, it might have been a better idea to not use LINQ. But we are here today, and I have used it.
What's a good example of custom query builder?
The only one I can think of at the top of my head is the WMI, the Windows Management Information that Keith Patowski wrote. Yeah, that one's very cool. It's quite limited, but it shows you it's beyond map and filter. Yeah, that's quite interesting. Look at that. So who here has attempted to implement IQueryable? Yeah. Yeah. So how did that go? Was it fun? Did it work? Yeah. Okay. So yeah, you probably know what I'm getting at here with this. IQueryable is not fun to implement. It's littered with mines. There's a great deal of problems with it, and I'm now going to show you some of the problems. So, who here knows about this tool called GraphViz? You know about this tool? It's a really old tool, and I didn't know about it. It's a mini language called Dot, and what it does is it draws graphs based on this very simple language. And if none of you have heard about it, then you might get at least one thing out of this talk today, which is GraphViz. It's really awesome. And I didn't know about its existence until long after I'd finished most of the hard work on the SQL provider. And if I'd have actually discovered this tool way back when I was writing with Dynamics, it would have made my life a hell of a lot easier. Yeah, and yours, yeah. Yeah, because LINQ, it creates some pretty crazy trees. And in order to visualize them, you're kind of stuck unless you're going to write your own graphing thing. So I was, you know, working with the Visual Studio Debugger on my big whiteboard and trying to draw these trees to try and understand what the hell is going on. And it was a lot of pain. And then much later I found this brilliant tool called GraphViz. So I wrote this script which processes link trees and it draws graphs out of them. And I've got a couple of debugging hooks in the SQL provider. One which shows you the SQL that's being generated before it executes it, and another, this one, the LINQ expression event. And what that does is it passes the LINQ expression. It raises it as this event so that you can hook into it. So I can hook my script up like this. Right. And now every time I evaluate a LINQ query, it will graph it for us. Okay, so this might be quite interesting if you don't know anything about LINQ. Oops.
I think it's the run.
Okay, so I mean, this is about as simple as it gets, obviously. This is just select. Yeah. there's a static method called to select. On the left side of it is the input, which is this IQueryable or SQL entity. And then here it has this quote node. Each one of these boxes is a node in the LINQ expression tree. Okay? It has this quote that usually appears before lambda expressions, but doesn't always. And then you have this lambda, and it's got this argument here, and then the expression of the function that it executes. So this is just the same because nothing happened. Right, so we'll see how this changes over time. And how there's a lot of things that can trip you up. So this next query, it uses where, and it uses my custom operator, if you like. And then it just selects C again. So, okay, it's generating 2 graphs. I'll fix that in a second. Because I ran the event handler twice. So this is not too bad. I mean, you can see it's probably what you would expect having looked at the last graph. But an interesting thing to know here is it's just where. It didn't call select at all. And if you know LINQ, and if you was not to use a query expression, and you was to just use the where function, then that makes sense. But there's a few things in it that will trip you up like this. And actually, some of these simpler cases in the query expression are the ones that are right hand to hand. This being one of them. Okay, so it's not too bad yet. You can see here that it calls the get column method, which is through the quotation, and it's going to get contact name. Okay, and this is the operator equals %, which is the like operator, and it's going to match it to this J percentage. Okay, wonderful. So,
what if you take this query expression and rewrite it using dot notation and not the sequence? Should you get the same expression?
same thing, yeah. Yeah. Well, it should be in theory because that's what it does, right? It translates it to the same sequence as well. Well, that's what the F-sharp compiler is doing. So, yes. Right. So this is where it's going to get slightly more interesting. So here is this select many syntax that I showed you earlier on a foreign key. Yeah. And then there's a where clause as well. Right. So now you notice as well that for each tab here in Internet Explorer, that's another tree that it's giving you, and it gives you more than one tree depending on the way that the query is structured, and depending on how you change the lines around, you get more or less trees, and it changes quite significantly, even though the overall result of the query is the same. This is why IQueryable is not very much fun. So this is select many, and on argument 0 is the input, same as before, and then the argument 1 and 2 is a lambda expression for each, where argument 1 is the stuff that we're going to be selecting, and argument 2 is the lambda expression on how to project it back out again. This is bigger than it needs to be. We have this create related call that's got 7 arguments. The only reason it's got so many is because you can't in type providers you can't quote complex types. You have to quote simple types. So this stuff is just all a load of strings where we could have made it a bit simpler. But yeah, looking through this, you can see that well, probably some of this isn't really necessary, but it calls this get data context in the instance. I showed you that quotation earlier. But a key thing to notice with this is that, and over here somewhere, it creates this tuple for you, right? Because now there's 2 entities. And the reason why this is important is, if we then look at where, you see now this is an IQueryable of tuple of 2 arity, where there's 2 SQL entities. So when operator equals % gets called in it now, it has to know which side of the tuple to get, right? And what this means is that if I swap this around to illustrate this.
Are those expression trees can be further simplified, or are they already simplified?
Well, yes. I mean, this is part of what I do with it, right? The idea here is that I don't try to simplify these trees. I try and pick out the bits that are interesting, and then I fill in some missing information. Then I reduce it down to the simplest it can be. But we're not in control of how these trees get generated.
So So sharp compiler doesn't do a good job of simplifying expressions?
No, and the one thing I haven't tried is comparing what the F-sharp compiler generates compared to the C-sharp. And I assume it will be identical because there must be some kind of specification that shows them, what they must generate given set of inputs. If they were different, then I'm not sure how that would work. It's something I keep meaning to look at. Okay, so in this case, where was first? You see here, this parameter name is C. Like we know it's called C. Yeah, it's definitely called C, which is wonderful. So when you just think in terms of as you're parsing these trees and you're building up this information, let's just put that in there again. Okay, let's assume this was just some different criteria. Now in these link expressions, you can do this, right? You can put where anywhere you like, and you can have multiple terms which are and or expressions, and you can then just reapply more stuff later if you want. It's totally valid link. Obviously, this is useless, but we'll just illustrate one of these problems. Right, because now this where, we know this is C, okay, and then this select many happens, and all this crazy stuff happens, and then it tuples this stuff for you. So now you've lost the name. Right? So now this is R0 and R1. So now this where, although this is the same code, now it's referring to R0 of this tuple, right? So you, in the code where you build this stuff up, you need to realize that something that used to be called C is now being tupled away, and that further references to the argument 0 of the tuple actually means the same thing. Because obviously when you generate a SQL, you need to make sure that you're doing it correctly. And there's loads of stuff that will trip you up like this, especially with it going and renaming things. So, right, one other thing I want to show here is join. So this is an explicit join as opposed to the select many, which is actually slightly simpler. That's join in all of its glory. Yeah, look, this stuff is can certainly be simplified, right? A lot of this is just noise. But actually, this is not too bad. It does the same what you'd expect, and then it tuples the stuff here, which is great. So then the result, right, well, another nice bit with link here. Actually, this is a select. No, there's not a select here, you've just got a join. There's a select at the end, but there's also a select at the end here. And what this is for some reason with the join, it also fires another select that it just triggers these two property gets. As far as I can see, this whole tree is completely useless, and I actually completely ignore it. It has no point whatsoever. So that's another bit of fun. Now, what I wanted to show is the interaction between join and select many. And when you put these two together, some interesting things happen. So in this first case, we're going to call join first, then select many. So there's join on its own. And then there's select many, which is graph is struggling to draw these now, but okay, but they're still on their own, and it still kind of makes sense. But if you swap these around, so what now you only get two of these graphs, because this one is
very large.
yeah, right. So what happens in this case is that select many actually uses argument one of select many is the join, right? And if you nest these together, this is what you'll get. You'll get one massive tree that joins them together, which is not a problem, right? You can recursively process this stuff if you're expecting it. But you need to be aware that depending on the way you use the syntax, it can quite drastically change the amount and the structure of the trees that you get. So, and for example, here, as you've seen, what happens when you put where in, what would happen if we had 3 select members and a join, or whatever, you get this huge tree, but then if you used to put a where in the middle of it somewhere, then you might get one sort of big tree and a where on its own, and then a second sort of big tree, and this stuff, yeah. So to try and deal with all combinations of it can be quite tricky. And as you can see, there's a lot of noise in here as well, right? Okay, so this is why you don't implement IQueryable for fun. So this is a bigger query, we'll just run it just for a laugh. 1, 2, 3, 4. This one ended up with like 5 trees. Some of these names, these are actually being replaced with shorter versions in my script, including that one. Yeah, so big fun. So now I'm going to show you how we can deal with these problems. And for the F-sharp experts in the room, you're probably not going to learn a lot here, but for those of you who aren't, this might be quite enlightening. Apologies about this thing. So, active patterns. One of my favourite features in F-sharp. But it took me a while to understand how to use them properly, because active patterns are really cool. And when you first learn about them, you're like, well, great, I can see that you can decompose some data, and then I can use them in a pattern match, but equally I can just call the function. So where's the real use in it? And it was only when I started to do a lot more of this stuff that I've just been talking about that I really saw where the power comes from. So this is some examples of some of the patterns that I use in the SQL provider. And in order to show you how this works, I'm going to do a very, very quick recap on how to pattern match with lists. So in F-sharp, there's like 4 main types of pattern matching, which is records, tuples, lists, and discriminated unions. And we're only actually using lists here. So I've got a function here that pattern matches on the list. Can everyone see that one? So this is the empty list. That will match on the list that's empty and only that. Obviously the wildcard is a catch-all. And then you can use the classic cons matching. So this will match a list that has at least one item in it, which is extracted as H, and then the tail, which might be empty, or it might represent more items. And this can be used recursively. And equally also, which a lot of people don't realise you can do, is you can do this. I mean, you can keep cons in these together. So now that matches on a list that's got at least 2 items. Right. The other style of pattern matching you can do with lists is like this. So this pattern matches on exactly 3 items in a list and nothing else. Also, you can take this concept one step further. So if I put 1 in here, that will now be inferred as it's matching on a list of integers, and that list of integers must have 3 items, and their first item must be 1. Right? And also you can apply when bars to this and what have you. But yeah, one thing to note with this is that you can nest these together, which is another thing that people don't realise to start with. So if we assume that X, Y, and Z here are actually other lists, I could say, right, well, X should also be an empty list. Or actually X should be a cons pattern that matches ahead and any amount of items that I don't care about. And you can nest these to any amount of level. And it's this behaviour is what makes it so powerful when you combine it with active patterns. So if we look at some examples of active patterns above, we'll look at this one first. This one's used everywhere in the SQL type provider, and it will be if you're doing anything with LINQ expressions. This is the method call pattern. This is what we call a partial active pattern, which means it will either be a method call or it won't. And it returns some of some information if it is, and none if not. And it takes in an expression object. This is the base class of the LINQ expression trees, and it has this property on it called node type. right? And that is like, it's an enum, and it tells you what type of class this actually is that you can downcast. So in this case, if it's the expression type of call, which we know to mean that the expression is actually a method expression, then you can downcast it here as well. Okay, so in this case, if you assume that the expression is actually a method call expression, you could then return some information about it. So this is where it starts to get quite powerful. Yep.
So like, are there other things that would be a method call exception except for call?
Yeah. No, one
Yeah, yeah. Although that's yes. But I don't think it's possible for you to create them, right? If you create a method call expression in the base in the constructor, it sets the node type here to call, right?
Oh yeah, I just mean like when you pattern match on the type, like with that expression,
Yeah.
it selects on that too.
Yeah, but because it works left to right, right?
It's a
If
bit
this
faster.
bit matches, this bit doesn't never tend
But
to
is
see.
it possible because of expression of type of method call expression, but no type will do something different?
Well, in theory, yes, but in practice, no. Because the way that the object construction works doesn't allow it. And I don't think, like, for example, you can't change this. You don't have any access to change that. So when this thing gets created,
Yeah.
it implicitly sets this to the correct thing. This is like a classic object orientation hierarchical structures. Yeah? It's not ideal, but that's what we have to work with. So in practice, yes, we understand that if this is called, it will always be a method call expression. And this is the F-sharp compiler is generating this stuff. So it's a safe enough bet. But yes, in theory, that could be a problem. Right, so here, this object, which you'll see is another expression. This will either be null if it's a static method call, or it will be another expression that represents the object that the method is being called on. Okay, so in the case where it's null, we return none. Otherwise, we return the object itself, which is another expression. Then the second bit we return is this method, and that is what this is method info, which system reflection gives you, right? The standard reflection stuff. And thirdly, and this is where the power really starts to come in, is this guy. So this is the list of arguments that get passed to this function or method. And they are also expressions, right? This is another list of expressions that represent the arguments to this method call. So what we do here is we turn it into an F-sharp list and return it. So now in our pattern match it, you could use method call, and we understand it's going to return 3 pieces of information, right? All of which we can ignore if we want, like so. So now we understand that the first element here is going to be some or none, depending on whether it's a static method or not. If we don't care about that, we can just leave it. Or I'll put none in there because I'm interested in a static method in this case, let's say. Okay, right. Let's just briefly look at this other little pattern here. Method with name. So this takes in a name, and it also takes in a method info object, which is from system.reflection. The same as this, right? And then it matches and says, well, is the name of the method the same as this? If it is, then it just returns some. It doesn't actually do anything. Otherwise, it returns none. So now you can nest these two things together very easily, as we understand that the second parameter here is going to be a method the method info data. Like I say, method with name join. Right. Okay, so now this will match on a static method called join, which has an empty list of arguments. Now the list of arguments themselves, they're all also expressions. Okay, so here I've just said I expect none, which is obviously not going to be much use. But let's just say, for example, that these expressions here, they're all, one of them might be another method call, right? So say I'm not interested in the first one, but I understand that the second argument is going to be join.
I think the comma underscore needs to be outside the parentheses.
Oh, does it?
No, maybe.
Well, anyway, you get the idea. I was going to stop here with it anyway.
No.
Because I wanted to illustrate the power that you can get with nesting these things together. Right, which I'm sure you can start to see from this. So what I want to do is show you some of the patterns that we use, and then show you progressively how they get composed together to form bigger, stronger patterns, and then actually how they're used to distill some of that crazy link stuff that we were looking at earlier. So you see this stuff a lot in, if you look at CRM or Freebase, you'll see a lot of this stuff going on. And some of them, a lot of them are very similar, like they just take some information about, depending on what node it is, and just return it. But some of them do some slightly different things. This one, for example, which I didn't write, and actually the guy that's done this has actually broken another area, which I just noticed today, this code. So I'll be fixing that later. This is what allows you to use the array expression syntax, and he replaced it so you can work with any sequence, which does work, but now it doesn't work with the array syntax anymore. Which is why I didn't run that query earlier, because it would have crashed. So I'll be fixing that later. But this one's a little different because actually, it goes through this enumeration and it finds the expression and it creates a lambda expression from them and actually compiles it and invokes it then to actually extract the data out rather than it just being this abstract tree of data. This one is one of the most important ones and it's used everywhere and it's also used to compose more complicated patterns together. Often it does what you would expect, right? It gets the property information. So, okay, this is one that I wanted to point out. So if you remember in them trees, you keep seeing this quote that appears everywhere. And the quote is actually really useless. And sometimes it doesn't appear when you expect it should. Most of the time it does. It always appears before a lambda, but there's in some places it doesn't, or some places it pops up where you don't expect it. So this one is not a partial active pattern, right? It always returns another expression wherever you use it. But this is quite clever. Although it's very simple, it's very powerful as well. It just says, right, is this a quote? And if it is, I'm going to return whatever the quote points at, as you saw it in the tree, where everywhere we've got a single quote and it points at another expression. And if it does, it returns the next thing in the chain. And if it's not, then it just returns itself again. So this is pretty powerful because wherever you think that a quote might appear, you can just stick that pattern in and it will always deal with it for you. It's similar to this one as well. It does a very similar thing. So if we just move on a little bit, this one you'll see all the time as well, and it starts to nest stuff together here, and use some other pattern matching techniques. So in this case, it uses this optional F# option value, which I just scanned through below, and it expects that the first parameter will be a method call, which will be on an instance of an object, which is O, which actually is used later. And then the really powerful bit here is that the second parameter, and I showed you this stuff earlier where we use with method name. In this case, I'm trying to match on when the runtime entity gets one of the common get methods called on it. But there's two of them. Because I support using F# option types in case of nullable columns. Yeah, so there's two different functions. So what this pattern does is it says, right, well, I'm going to match method with name get column, and I'm going to bind it to mem. Or, and this is wrapped another set of parentheses here. Or I'm going to match on a method name with get column option. I'm going to bind that as meth as well. As long as you balance them two together, it will work. And additionally, at the end here, I say, well, I expect that there'll be one parameter on this method, which is the name of the column that we're attempting to select. And because both of these methods only have one parameter, it allows you to actually just bring all of that data into the one pattern, which is extremely powerful. And this sort of stuff is used in various other places in the SQL provider. Okay, I think, right, that's it. I'm going to show you now how some of this stuff is used all together in order to actually process these expression trees from LINQ. Now, this stuff looks pretty crazy at first, but when you realise what complexity it's distilling, it's actually very simple. And the equivalent implementation of something of what we're going to see in this file, starting here, is thousands of lines of code in another language, namely C#. So this is actually, if you've ever implemented IQueryable, this is the implementation of it here, and this is the function where you get past the expression from the F# compiler. And as you saw earlier, we match on many trees. Sometimes them trees have to be recursively processed, and sometimes they don't. Okay, so then literally these ones are really simple. We say, yeah, we're going to match on a method call which is static. It's going to be called skip. It's going to have an amount and the IQueryable source. These ones are very simple. And here again, with order by, it wraps two packs together. Right, skip some of these. So where things start to get a bit more crazy. Now, if we understand what where has to do, when we see where, we understand that we're going to get a tree which is going to contain a series of and or expressions, and it could be of any depth. And then when those binary expressions stop, on the leaf of that there's going to be another expression tree that actually expresses the conditions of the where, right? So here you have to first recursively process the and or expressions to any level, and then when you finally hit the leaf, you then have to process them with your patterns that match on the total possible things that you support in your where clause, such as matching SQL column get to a constant, or two SQL column gets together, or using an array expression and so on. So let me just skip down here a bit. There's this recursive function here that does the whole. This looks like it could be produced, but it can't. It's not that I've really tried. I don't think it can be. But yeah, it basically deals with any combination of and also or else the expressions. This pattern is quite useful as well. I'll say, I went to source. Okay. But you can imagine what this does. Because and also and or else, they're both the same thing. They're effectively a binary expression with two other expressions. So that pattern matches on either of them. I don't care what they are, and then it allows you to find them out. Okay, and then once that's processed, there's this one at the bottom, which is the condition. And the condition pattern is defined up here. And this is the guy that actually matches on. There's some special cases here. And then these guys are the ones that match, say, the constant with the SQL column get. So you saw some of these patterns earlier. Okay. So you can see some of these get quite wild, but it's very, very powerful. And in fact, when I added the ability to use S# option types into this, it was really easy because I changed the runtime representation, I added a couple of patterns, I stuck the things in here, and it all just worked. And I wrote that, I completely added option types in about an hour, and it worked really well. And if you did the equivalent implementation of this in an object-oriented language, by this stage you would have ended up with 2, 3, or more visitors, all with mutable state. And if you then try to change that, to add new functionality in, that can get quite hairy. Not that I have anything against the visitor pattern, it's very powerful, but this makes it way easier. Okay, so I just want to show a couple of the others on the things that we were concentrating on earlier, namely join and select any. So just this on its own is so powerful to be able to just express all of this. This essentially, that big join tree that you saw earlier, just allows you to mask away all of them nodes in a specific order and extract the bits of information that are actually relevant to what you're trying to do, all in one hit, and also ignore all of the crap that you're not interested in. And once again here, there's a lot of nodes like this optional quote, which is just a wrapper, and then there's these lambda expressions. I don't really care about the lambda expressions. What I really care about is the name of the parameter that it's pointing to, and the fact that it's matching on this method call afterwards. I don't care about the method call. What I do care about is the parameters of the method call, and what the names of them are. So it's effectively like a template to say match this whole tree and extract these very fine pieces out. that allow me to then do some stuff and create the data that I need. So similarly with select many is actually slightly more complicated. As you saw earlier, these can be recursively have more select menus and more joins as well. So in this case, you don't have to specify a very fine-grained tree. You can say, well, I'm expecting some bits of this tree, and then I've got this inner expression and a projection expression. And just give me them as their whole tree. And then I can then recursively process those guys with this call, which matches further on select many calls. So yeah, some of these patterns are quite crazy. But yeah, what they're distilling, the complexity of what they're distilling this is pretty amazing power. And actually, this implementation, that's it, I think. Yeah, the rest of it's just noise. So there's about 300 lines of F# there, and that's the equivalent of thousands and thousands and thousands of lines of C# code. So I think that's pretty important.
Can this library of executants can it be used for other terms?
Yeah, it's mainly the pattern, right? You can take this patterns file. A lot of it is just general, especially all the stuff at the top, where it's literally just decomposing the LINQ expression stuff. When a bit later on, when they start to get composed with my runtime objects and things that I really care about, then you cut them out and just write your own for whatever you're doing. But yeah, by and large, you can certainly reuse these patterns. Alright, so the last bit I want to talk about with LINQ is this. I'm just going to leave it like this because it's easier than messing about with you can still see that, right? So the projection. Now I mentioned the projection briefly earlier, and this is, you might not have really considered it yet, but this starts to get a little bit complicated. Because in our projection, you can say like, yeah, so I'm interested in C.contact name, and I'm also interested in some order, piece of information about an order, or you might select an entire sequence. Or equally, you can create a new F# an instance of a record type that calls functions on things, and it can be any F# expression. And this presents us with some difficulties, and the reason why is because, of course, as you all understand, we're writing a SQL query, and we're joining to other data, and what you effectively get back is you get back flat data rows, where all the information is duplicated in each row. We're not actually getting these entities back; they don't really exist. Instead, we're getting this data row back. So, in the projection, when we're saying yes, I'm interested in some property of A, it needs to understand that actually that's not what I want. What I really want is some piece of information from this data that's being returned, which is going to be aliased in a certain way. So what I did to get around this is I have this notion of there is a master entity that gets created for each data row that comes back. And then for each other entity that gets access through that, it essentially knows about the alias that it was given in the link tree. And then what it does is it creates another entity out of that data, which is cached. And it wipes out all of the alias information. So as far as you're concerned, and it's concerned, it looks like another SQL entity. But in reality, they're all actually sharing these rows of data underneath. But there is a little trick to doing this, and that is that you're still only getting these calls to get column, right, in your projection. But what we actually need to do is call this other function that I defined that does the stripping out of the alias information and creating the new entity. So in order to actually get this to work, you have to modify the LINQ expression, the projection, and you have to transform that. And wherever you see a piece of information that we're interested in, it needs to be replaced with these other calls. So that's one thing that the projection has to do. And the other one is it needs to analyze what fields are being selected in order to write an efficient bit of SQL. We need to understand that whatever size projection, if they've only actually selected C.contact name, regardless of the fact that the query is joined to 6 other tables, that we're only going to go and select that one name. But equally, it needs to understand that although contact name might have been selected on its own, maybe C has been selected in its entirety as well. And in that case, what does it do? And in that case, what it does do is it goes and selects everything, no matter what. Otherwise, the entity wouldn't work. So there's some little tricky bits involved in that. There's not much code, I'll show you. And in order to do this, I use the visitor pattern. Well, not exactly. So in C#4 or .NET whatever version, we'll stick to saying C#4, they gave us a projection, a transformer, like a visitor that enables you to override certain bits of it, and you can splice in new expressions into the tree. So it's actually a good fit for this. That's exactly what I need to do. If I can find it. No, this is it. So yeah, you inherit from this thing, the expression visitor, and then this is actually a nice synergy between the two things, because although I'm using a mutable C# transformer thing, you can still use your pattern matching in here as well, using all their patterns. And there's some nice examples again of using these quite complex nested patterns here to pick up on bits of information that indicate that a certain field has been selected, so that I can remember and reason about how to create queries later. And actually, this one's pretty awesome. As we saw earlier, that depending on how the queries have been structured, sometimes the information's been tupled, and sometimes it might not have. So, in order for me to understand, has get column been called on a certain entity? Well, it might be on an entity, or it might be indirectly on one of the items of a tuple. So, once again, to do this sort of stuff in C# is really very difficult. Whereas in F# using these patterns, I can express all of them different possibilities in one pattern, which is what's happening here. So this metrical, as we know, some means it's going to be an instance. Now the instance might be either this parameter name that just matches on a single name, that would be if there wasn't a tuple. Or I'll match on a property get, which will be a tuple. I'm not interested in the first bit, but I know that the second bit will be the name of the argument in question. And then either way, I say, well, I don't care, I'm either interested in get column or column option, and give me the key. So if you think about the amount of possibilities that actually eliminates there, you know, there's a whole bunch of different things that are just reduced into one very simple pattern. Very powerful stuff. And yeah, where the actual splicing stuff happens is here. There's some code up there I'm not going to go into that detects whether this is something that we need to, an expression we need to replace out, and then it literally just goes, okay, I'm going to replace it with this method info there, which is why there. F12 does not appear to be working. This guy. Yeah, which is that function that I was telling you about earlier. I literally just replaced it. Okay. Right, that is the bulk of it out of the way. So I'm not going to go through this stuff a lot. But yeah, just the extensibility, you have to implement this this MySQL provider interface. There's a few more methods on here now because we've got the CRUD stuff to do updates. But actually, although there's a ton of methods, most of them are very simple, and especially the first two are just creating connections in commands for whatever your implementation of ADO.NET is. And most of the rest of it is doing stuff like mapping types to your provider's types. And if the provider in question supports connection.get schema, a lot of that can be done for you. And actually, largely, most of this code you can take and just copy and paste it from one of the original ones. And in that sense, I implemented PostgreSql and MySql. It took me about half an hour to do both of those. And most of that work was working out how to actually get the schema. And then the rest of it was tweaking the SQL to work with that specific flavor of SQL. Because I don't know them very well. And I was able to just add support to whole new databases within half an hour to an hour. So that's really very cool. Of course, this one's the fun bit, where we give you this record type of information, generate a query from it. So this is where the optimization step can happen, and none of it's really optimized at the moment. It doesn't generate suboptimal SQL or anything because it's generally only doing fairly simple things. And once again, the implementation in all of the other providers is all the same. The algorithm is the same. So optimization aside, you can just take the existing algorithms and just tweak it for your SQL, and it will go and generate the SQL for it, which is great. And this is, enabled Colin Moore to do the Oracle implementation. It took him less than a day, and the ODBC implementation took less than a day as well from another guy. So that's pretty cool. Some of you might have seen this slide before. Cats. All your types are belong to us, which I now changed to all your SQLs are belong to us. F-sharp, ever taking over all data access stories. Right, so that is about it, but I have a word from our sponsor. So I'm over here tonight from these guys, F-sharp Works, which you might not have heard of yet, because it's a new little gig going, and it's comprised of Thomas and Phil and Matthias and Scott. And they offer F-sharp consulting services and training services. So yeah, you can head on over to their new website and check them out. And unless you guys want to see some of how the actual provider implementation works for a specific database vendor, that is it. So I'll take questions.
So like, what are your future plans? Like, where are things now, and what needs to be better?
Yeah, so there's a bunch of stuff that can be done. Yeah, where to start? There's a big outstanding feature list, but it's trying to determine what's more important. So we just added the create and update and delete stuff, which was, what we think would be the most important thing. I'd like to do things like nested queries and group by. Also, there's several other database vendors that we can attempt to get involved with. The store procedure support is a bit lacking, so that could be worked on. It could be a lot better. I've not really bothered with that because there's already a much better alternative, at least a SQL Server. If you look on GitHub, there's a list of suggestions and fixtures and things to come in. But yeah, we're all up for suggestions and ideas.
Got one off the top of my head that's been causing me lots of problems. It's often I would essentially you have like several database tables that look exactly the same, and you want to share code, but the way query currently works, it makes it incredibly hard to share.
Right, so that's like what I explained earlier, right? If you've got tables with the same names, if you use the create method with the unsafe overload that enables you to give it a stream of key value pairs, where the key is the name of the column. So if you've got two database tables that are the same, you use two data contexts, and then you just get data out of one and just insert it into the other. You just go create and use the other one's column values, and it maps the two together for you. So if that's the similar thing that we're talking about, then it already does that. Yeah, and it saves you having to do that explicit mapping as long as the column names are exactly the same.
Yeah, exactly.
Yeah, which is a really powerful thing because that is something that a lot of people have to do well.
Yeah, it's annoying because you write a complex query, like nested queries in it could be like 15 lines of code, and then you essentially have to cut and paste it for every table.
Yeah, okay, it depends on what you're doing, right? Because then you're talking about bringing the stuff down to the client and then pushing it back. Like, depending on in terms of efficiency, how much data you're working with, this could be a really easy way of doing that. Plus, you get all the benefits of the transaction update.
In this case, it's a very narrow table, only 4 columns, essentially, but they're different data sources, so they have different tables. That
Yeah, so it maps perfectly to that. One other thing to answer your original question, I was trying to think of other things that we need to do, and one is to have some idea of a lazy, like streaming implementation. At the moment, it loads everything and creates these entities and it gives you everything back. So you can't use it, you can't select millions of rows. But it's fairly simple for us to do something where you use a static parameter and say, I want this to be lazily evaluated. And then when you call it, it gives you back a tuple and a string where the first element of the tuple is something that you have to dispose when you're finished. And then you can evaluate it as you want. So that would be a nice thing to do as well.
Does it work on the SQLite works on the Xamarin Node?
Yeah, so the SQL Provider works on Linux and Mac. and Mono. And in terms of SQLite, yeah, it works on all of them. And with Rachel Reese has been getting into work with mobile profile as well. So with the mobile profile, the only problem is that the query expressions aren't fully supported. But there's a specific version of fsharp.core that if you build it against it, it should work. It hasn't been tested that much yet.
That's
But
what they've told me today. But if I won't use query expression, but I'll use the dot notation and numbers, it should work on the existing version as well, right?
yeah, I don't know actually. Yeah, I'm not sure if the restriction there is purely because of that syntax, the query syntax, or if it's
I think it's very simple.
right.
Okay.
In that case, yeah, it should work. Yeah, one thing to note though, you know, you can't just go sequence map filter. That's not going to generate the query.
Yeah.
I'm going to try that now. Yeah, if that works, that would be awesome. Because obviously, you know, that opens into the world of mobile devices and things as well, which is pretty awesome.
Yeah, the ideal goal is that you can have all of these
Yeah.
like any database.
Yeah, and you can actually, it's great because you can use the same type provider to move data between your MySQL database or even Oracle and your spreadsheets into, you know, in a mono environment.
Like you could, for example, have a SQLite baked into your app that is like your bootstrapping information that you could just bake in really nice and easy and then shove it all in whatever database. Yeah. Sounds cool.
No other questions?
Thanks, man.